2025 A-Level Combined Mathematics Paper 1 Part A, question number 4. This question has to do with the binomial expansion. The question says, let n, which is an element of the positive integers, be an odd integer, which means that n is some kind of odd integer. It is given that the binomial expansion of the square root of x minus x divided by n raised to the power of n contains an x squared term, meaning that the coefficient of x squared in that expansion is not equal to 0. And then it says, show that n is equal to 3 and find the coefficient of x squared. So we're asked to find that n is equal to 3, which means that all of this stuff up here is somehow enough information to find that n is equal to 3. And then given that n equals 3 value, we're asked to find the coefficient of that x squared term. To start off with this kind of problem, you probably want to find the binomial expansion of this thing. Now in our case, since we only want to consider a single term, the x squared term, we can get away with not writing this thing as an expanded sum. Instead, we could just write the general term in that sum, and then considering the general term, find what the value of r needs to be for that term to be an x squared term. So we can, instead of writing the entire sum, just write that we want to find the general term of the x square root minus x divided by n raised to the power of n expansion, and when we do that, the general term of this expansion here is going to be, according to the binomial expansion, n choose r times the first term to the power of r, so that's going to be square root of x to the power of r times the second term, which is minus x divided by n minus x divided by n raised to the power of our final value n minus r. So therefore, this right here is a general term of the expansion of the square root of x minus x divided by n, all raised to the power of n. Now we can simplify this a little bit, since this term here has an x term and this term here also has an x term. The two could be combined to a single x term. So if we do that, first off, we can write n choose r, and then the square root of x can be written as x to the power of a half, and when you take x to the power of a half to the power of r, you get x to the power of r divided by 2. So x to the power of r divided by 2. As for this part here we have an x term as well as a negative 1 divided by n term, which is a constant. So we can actually take both of these to the power of n minus r and separate them out and write that this is equal to negative 1 over n to the power of n minus r multiplied by x to the power of n minus r. And now we can group the x terms together, and we can group the constant terms that are not x terms together and write this as being equal to negative 1 divided by n raised to the power of n minus r times n choose r multiplied by x to the power of r divided by 2 times x to the power of n minus r. Now when you have this from index rules, we know that this is going to be equal to x to the power of n minus r plus r divided by 2, which if you simplify is going to be equal to x to the power of n minus r divided by 2. So now we have this as being the general term of the expansion of square root of x minus x divided by n all raised to the power of n. So for an x squared term, we need this power of n minus r divided by 2 to be equal to 2, since that is by definition what we need in order to get an x squared term. So we can say or we could just say for an x squared term, we need the condition that this power of x, which is n minus r divided by 2, is equal to 2, which then implies that if we simplify this a little bit, r divided by 2 is equal to n minus 2, and if we simplify it a little bit further, we get that r is equal to 2n minus 4. Now at this point we can see we have one variable on the left and one variable on the right, meaning that r could be anything provided a given n. However, there are not an infinite number of solutions for r given certain n's, and the reason for this is that this r can only vary in between 0 and n, because by definition in the binomial expansion, when we take the sum starts from r equals 0 and ends at r equals n, meaning that r can only take values between 0 and n. So we could write this equation as equation number 1 and then write the condition for r saying that r must be greater than or equal to 0 and less than or equal to n. This is the second condition, and this condition comes from the binomial expansion summation. So we need both of these conditions to be true at the same exact time. If you consider the first half of this condition, which says that r must be greater than or equal to 0, and you say 2 and 1 together and you apply the logic, since r is greater than or equal to 0, 2n minus 4 must be greater than or equal to 0. So that means 2n minus 4 is greater than or equal to 0, which implies that 2n is greater than or equal to 4, which of course implies that n is greater than or equal to 2. On the other hand, it also means that 2n minus 4 must be less than or equal to n. So from the other side, we can say again from 2 and 1, we can get the logic that 2n minus 4 must be less than or equal to n, which means that if we rearrange this a little bit, 2n minus n must be less than or equal to 4, meaning that n must be less than or equal to 4. So therefore, we can say that this is one condition. We could call this like condition number 3 or something, and we could call this thing here condition number 4. So from 3 and 4, we get limited set of values that n could have. So from 3 and 4, n must be between 2 and 4 inclusive, which means that n is an element of the set of 2, 3 and 4. But of course, we know that n must be an odd integer. So since n is odd, we can say that in this set, the only odd value of n that we could have is n equals 3. So therefore, n must be equal to 3. So we have proven that the only value that n can have in this situation is n equals 3. So we've proven this again by the condition that r must be in between 0 and n inclusive, and the other equation that we derived, which says that r is equal to 2n minus 4, which means that 2n minus 4 is greater than or equal to 0, which gives us n greater than or equal to 2. And on the other side, 2n minus 4 is less than or equal to n, which means that n is less than or equal to 4. These two conditions combined mean that n is either 2, 3 or 4, and since only 3 in this is odd, we can say that n must be equal to 3. Now that we've solved that, we can finally find the coefficient of x squared that they've been looking for. So if we consider the coefficient of x squared from this equation that we derived over here, the coefficient of x squared is going to be minus 1 divided by n to the power of n minus r times n choose r. So here if we write the coefficient of x squared is equal to negative 1 divided by n to the power of n minus r times n choose r. Now in this particular case, since n is equal to 3, from equation number 1, we can find the corresponding value of r that's going to give us an x squared term. So that's going to be found from equation number 1. From equation number 1, we can see that our r is going to be equal to 2n minus 4, which is 6 minus 4, which is equal to 2. So n equals 3 and r equals 2 are the two values that we need to substitute into this expression here in order to get the corresponding coefficient of x squared. If we solve that, we're going to get, if we substitute n equals 3 and r equals 2 here, we're going to get minus 1 divided by 3 to the power of n minus r to the power of 3 minus 2 times n choose r, which is going to be 3 choose 2. Now for the first bit, 3 minus 2 is equal to 1, so we get minus 1/3 to the power of 1. And for 3 choose 2, from what we know about the choose function, this is going to be equal to 3 factorial divided by 2 factorial times 3 minus 2 factorial, or 1 factorial. Now simplifying this down, negative 1/3 to the power of 1 is going to be just negative 1/3, and 3 factorial divided by 2 factorial times 1 factorial is going to be 6 divided by 2 times 1, which is going to be 3. So that therefore our final answer is going to be negative 1/3 times 3, which is going to be negative 1. So therefore the coefficient of x squared in that expansion is going to be negative 1. So here we can see we have first found the general term, and then for an x squared term we found the particular condition that's required. We then used a bit of cleverness to realize that r must be in between 0 and n, and then given these two, we rounded down the possibilities for n, saying that n must be an element of the set 2, 3, 4, and then since n is odd, the only solution here is n equals 3, and then for that n equals 3, if we found the corresponding r, we substituted them into the formula that we found previously in order to find the final coefficient of x squared, which is going to be negative 1. Finally, if we consider the marks given here, for finding the general term and substituting into the binomial expansion and getting into this expression here, you get 5 marks. So you get 5 marks here. Now this 5 marks doesn't mean that you can directly write this expression here. You need to substitute directly into the binomial expansion first and then simplify. After doing that, if you identify the condition required for the x squared term, that being that the power of x must be equal to 2, you get another 5 marks. So for this condition here, going from here to here, you get another 5 marks. After that, when you realize that this value of r must be between 0 and n, and therefore you can round down your possibilities for n and you can get into this set here, you get another 5 marks. And then after that, when you figure out that the value of n is supposed to be 3 and the value of r is supposed to be 2, you get another 5 marks. And after that, when you substitute that into your previous expression for the coefficient of x to the power of n minus r divided by 2, as in when you substitute the particular value that gives you x squared into that and final answer of minus 1, you get another 5 marks. So that is the distribution of marks for this kind of question. You can see you need to hit each of these individual points in order to get the total marks. You need to find the general term, you need to solve for the particular condition for that general term that gets you the x squared term, and then you need to narrow down your possibilities of n, you need to find the single value of n and the corresponding value of r that give you the x squared term, and then you need to substitute them into your final answer in order to get the actual coefficient of the x squared term. So that's going to be all for this video. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.